dia tumbuh, orang akan alihkan dia daripada plastik tu masuk ke dalam tanah kan. Tapi ni kita tak payah buat dia, tak payah cabut, kita just terus tanam dia dalam tanah. Sebab dia akan biodegrade juga. Ikut condition dia. Penting.
Ha? Memang apa?
Scenery.
So basically what makes our product original is from the other products. Basically we use the artificial waste instead of the sodas or the tank.
Used to guna a lot of heat and carbon emission yang tinggi kan. Jadi kalau nampak yang pakai pasti boleh grow. Strength dia various. Dia boleh ikut jenis waste yang kita pakai dengan jenis fungal yang kita pakai. Yang ni kita orang tak testing. Tak testing lagi.
Introduce myself. So I'm Ellesa and this is my teammate
Irfan.
So basically this is the project. Basically this project is the continuity of our final year project. So in this project we utilize the agriculture waste to produce the Mycelium-Based composite, as you can see in the one thing here. So basically here is all the types of the Mycelium-Based composite that we have been produced. And here we notice that in Malaysia we have a lot of plastic pollutions, right? And also the excessive waste of the agriculture waste. And here in this project, as I mentioned before, we use that waste to turn it into the more useful things like this Mycelium-Based composite. So in this project we integrate the circular economy principle. So what makes our products original or unique from the others, we use the agriculture waste, as I mentioned before. So here is types of agriculture waste that we have been used. So from the research and also some experimental, we has decided that the few of them suitable for various
things.
So as you can see, for the packaging, bricks, and also so on. So maybe for the packaging.
For the packaging, we use the oyster mushroom. As you can see, it can absorb all the impact here, and also strong. Even though we use oyster mushroom, and as you can see, you can compare the oyster mushroom and also the Ganoderma. We use two different type of fungal. So this is Ganoderma. You can try to break it, and this is type of mushroom. So different fungal give different properties. And also the agricultural waste also give a different properties for the product. So means that we can combine a combination and give a various type of application and in various area. So first of all, our packaging, and then this is the industrial material. We can use as bricks. We can make like temporary house for people, and also chest set and biodegradable products maybe. Because we can see in the agriculture, people use plastic type plot, right? They seed and then they need to remove it and then make it into the soil. But this one you can just tanam, and then it will degrade. So for the panels, we will use this in the building because it will insulate heat, and as demonstrate how the properties of the fungal itself, it cannot burn even though we put it into the fire. The flame will not happen. And also, if you touch it, it will heat just a moment, and then it will not heat anymore.
It will cool down.
Yeah, it will cool down. So as you can see here, this is the degrade properties within 3 years, 2 years and a half. And also this is the first batch of our products.
This aged for 1 year and a half, like that. 1 year and a half. So basically, if you want to make it last longer, you can use another coating, water resistant coating for the brick and so on, so that it can last longer to degrade. And so basically, for this process, the process for all these materials is just simple. So basically, it consists 5 steps. We're gonna start with the agricultural waste preparation, where we're gonna shredded them into the small pieces, and then we're gonna sterilize it. And then the next one, we're gonna mix it with the fungal mycelium, and it become like this. So after it become like this, you can touch. It's safe to be touched. So after it become like this, we do it the composite fabrication like this. So basically we put it into the mold and do the shapes that we want, like the packaging, the test set, and also the interior designs material. So after we have been like do the composite things, next we gonna heat them like 2 or 3 days to inactivate the mycelium so that it can be safely used lah.
Or else it will be soft and then break. But this one, after you dry, it will kekal macam tu dia punya bentuk. And then for the testing and result, we can see the paddy stalk. This is paddy stalk. We use agriculture from paddy stalk. It grows faster than most of the substrate and also the empty fruit bunch. This is from the palm fiber. It takes within 2 weeks to grow, and then can be fully covered. If you put it into the very good condition, it will be white. But if it contaminate, it will be like this one. And then for the mechanical properties, flexibility and the compressive strength, banana trunk give the best. Banana trunk, this is banana trunk, will be give the best the flexural strength and also compressive strength, the paddy stalk itself. But we don't test using the Ganoderma yet. Yeah.
Carbon emissions.
And also for the production, it uses less carbon. Let's say if people in industry want to make a brick, it will heat and release a lot of carbon footprint, right? But for this material, we don't release a lot of carbon into the space. And also we utilize the agricultural waste and to counter the plastic pollution, petroleum product production. Even though they can recycle, but only 9% from them that can be recycled.
Yeah, and also our product is also cost effective compared to others. Like others in the market use the like ham, sodas, anything to make this composite. So instead of doing that or buying that things like which is expensive, we use the agriculture waste. So basically, agriculture waste is we get from the flea markets or from the factories. So we just go there and take the waste and turn it into this mycelium composite. Ada tanya-tanya soalan ke boleh je tanya?
Dah.
Boleh ambil our pamphlet.
Okay, so you test different agriculture waste, but you use the same fungus lah.
Yeah, no, the fungus, the mycelium is type of root from the fungus. So we use, this is Ganoderma lingzi, and this one is oyster mushroom. This one.
And then you need to like ferment it.
We're gonna incubate it like for a few weeks.
Few weeks.
What the cost of that?
To incubate.
Basically, we need the machine for that, the incubator itself.
So it will cost the electricity, but it not as
Do
high.
you require like other material to be purchased in the incubation?
As far as we use only for the incubators, and then we just like put this thing into the incubators
good
and then
environment.
incubate.
So we don't need any moist condition or cool condition because what we want to make is just the mycelium itself. People use the moisture and cool condition because they want to produce a large type of mushroom. So because our targeted is just the mycelium itself, so we just put it into the incubation, maybe the room temperature, and then it will grow.
Naturally, mycelium can grow itself like if we put outside, but to minimize the contaminations, we incubate it into the proper conditions so that it can be like proper produce lah.
Okay, and then if you want to scale up, how do you send this? You have a big incubator?
We just need the big type of room, and also it must be sterilized from the outside. And then we need a good airflow by putting a lot of maybe fans and also the filter for the air, so that the spore from the outside maybe can be filtered, and then the pure air can enter the room itself.
I think it's important to be like the room properly sterilized because if like during the incubation, if it contains, then you're gonna restart it back from the start. So I think it like cause
costless.
I mean, cost more if like it contains. So to avoid that, I think like to have the proper condition is important.
Then which application you think the most possible one with this kind of composite?
For the industrial, they have produced this type of packaging, but what we can see, they just use the oyster mushroom because it is very common in public. But let's say if you want to use different type of fungal like Ganoderma, you can use it, and then it will give the extra protection for the packaging. So this one have been used by the industrial, and also we can use this one, biodegradable product. Maybe people in agriculture, they put in the plastic first, right, and then after a few months the plastic will break into small pieces. But if we use this, it will act as like cockpit, and then we just gonna tanam dia lah macam biasa.
Right now it's very difficult to challenge the price.
Yeah.
Yeah.
Plastic. So that's the main difficulty of current sustainable product. Maybe that if you want to compete directly with the plastic, you need to find like unique way of utilizing this composite. Something that plastic cannot really compete.
Yeah.
Like you cannot break with the single use plastic dish, for example. But yet that this packaging is okay. The break is okay. Something that is the cost can be
Reduce. Alright.
Thank you.
Alright. Welcome.
Irfan.
Yeah.
So basically, our project is a continuity of from our final year project 2, which is where we make the agriculture waste to produce the mycelium-based composite. So as you can see here is the types of mycelium-based composite that we have been produced. So as we know that Malaysia has a lot of plastic pollution, right, and also excessive amounts of agriculture waste. So in this project, we utilize or integrate the circular economy principle, where we utilize the agriculture waste into the something useful like this composite. So what makes our like product difference or unique from the others, because there is also others company that make this product. So basically we use the agriculture waste instead of the sawdust that has usually been used by the others. So here, so not only we can reduce the waste, we also can reduce the carbon emission and also cost effective lah for the product to be sold. And so basically this product has, the process is just simple. We have a 5-step process, which is the first we're going to prepare the agriculture waste. For the preparation, we just gonna sterilize it and shred it and sterilize it. And then next we're gonna mix the agriculture waste with the mycelium fungal and incubate it for the few weeks. So it will become like this after the incubation periods. So after we incubate it, we're gonna make the composite fabrications into the mold. So we're gonna make it into this shape lah, the brick, the packaging, and also any interior design as you can see here. So after we have do the composite, next we're gonna like heat it for a few days, like 2-3 days, to inactivate the mycelium so that the mushroom cannot grow from this substrate. So I think after that we just test for the strength, the flexural strength, the compressive strength, and other mechanical properties so that we can apply into this purpose.
So for the fastest substrate growth, the padi stock has been grow like about 2 weeks, and also the FB one. FB is empty fruit bunch. It takes just 2 weeks to grow the mycelium, but for the industrial process, they usually use the sawdust. As you can see, the properties is just like the same, right? But the difference is the sawdust is more costly, but for this process, it just less cost to produce.
We just use the waste, the agriculture waste that we got from the flea markets and also from the factories.
Yeah, through testing, as you can see, this packaging can be thrown and cannot be broken. And also for this brick, we can utilize it by
to make a short-term construction.
To make a short-term construction, macam untuk rumah sementara ke, kalau berlaku bencana ke. And then dia punya kelebihan, kalau kita bakar, if we put it on fire, it will not burn. It will burn, but it will not cause the most the flame.
Oh, it's fire resistant.
Fire
Yeah.
resistant, yes.
As you can see in USA, there has been like kebakaran, right? So there is like only one house there that not be burned, which is the house that make from this brick, the Mycelium-Based composite brick. But that basically costly lah, because we need more innovations like the coating, for the water resistance coating to make it last longer.
And also the difference is usually the common fungal that people use is the oyster mushroom. But we innovated it by using a different type of mushroom. This is Ganoderma. As you can feel, it feel more hardened, more hard than the oyster. So this is oyster. It's more stiff, right? Yeah, but and also for the degradable process, this one can boleh bertahan at least 1.5 year. Dah
This
degrade.
one dah degrade after 1.5 years.
Okay.
So basically untuk melambatkan the degradation, you can do the coating like the water resistant coating or anything to make it last longer.
So what does mycelium do?
Mycelium ni dia just macam roots untuk fungi. Dia macam kalau oyster kan, cendawan tiram. Mycelium tu dia akar dia.
Okay.
Akar dia. Jadi mycelium ni dia act macam gum dia untuk lekatkan
dia natural
agricultural
gum.
waste.
Okay.
So dia lekatkan, so bila dah lekat kita bakar dia. Dia panaskan sikit untuk keringkan. So dia akan matilah. Dia tak akan tumbuh
The
cendawan
mushroom.
ni.
So basically if kita tak heat, dia akan keluar mushroom. So dia boleh like 2 in 1 juga. Instead of like biocomposite and also mushroom cultivation.
Tapi kalau dalam agriculture pun selalunya kita dapat tengok orang akan pakai plastik pot tu kan, tanam anak benih, lepas tu alihkan baru masuk dalam tanah. So basically yang this pun we can also use as the seed pot lah. Grow it in this and then tanam. So benda ni akan degrade and also benda ni act as baja itself. So kalau kita tengok orang yang jual mushroom betul-betul pun, mushroom yang cendawan tiram tu dia dah tumbuh kan. Jadi dia cabut, dia jual mushroom. Tapi yang tertinggal tu, yang mycelium tu dia akan jadikan baja untuk orang lain pula.
Okay.
Betul?
And you, macam do you try dengan kenaf ke? You have durian skin, you have palm press, you have sugar cane. Ada tak with other agricultural waste? Can it work with mycelium? Kalau macam kenaf or some other agricultural waste?
Dia kalau dia dah ada lignocellulose dalam konten dia ataupun lignin, dah kira okey dah boleh tumbuh. Cumanya yang bezakan dia adalah masa je untuk tumbuh. Macam contoh dekat sini padi khas, dia boleh tumbuh. Kalau biarkan lama-lama macam ambil masa setahun, dia akan fully covered.
Kalau
Tu pun ambil
EFB
masa
tu
lama.
kejap je, like 2 weeks and dia dah fully covered.
So yang membezakan dia adalah jarak masa untuk dia tumbuh.
Compressive strength and flexural strength pun berbeza ikut dengan ni lah agriculture waste tu. Macam kalau EFB ni dia macam okay kan. Kalau untuk strength tu boleh guna like coconut or anything so that dia macam stiff sikit.
Okay.
Kuat.
So tadi dia dah kata yang dekat forest tu dia boleh tahan api kan. So untuk demonstrate pun saya dah tunjuk kan tadi.
Nah, dah.
Dah kan?
Dah bakar.
Dia memang boleh tahan lah. Takkan ada api yang akan.
And dia akan panas sekejap je and then dia dah cool down. Dah boleh.
Is it at the end of the day, is it possible to create macam 3D printing filament? Let's say
3D printing filament.
from this material, mycelium, this combination.
For that time, I think kan because ada sekarang ni teknologi orang buat packaging. Lagi satu orang buat makanan sebab konten mycelium ni adalah protein, kitin. So protein tu kalau kita growkan mycelium dekat atas agar ataupun substrate liquid, dia akan jadi tebal. So bila tebal tu selalunya kita akan ambil, kita akan tekan-tekan dia sikit, lepas tu kita goreng. Benda tu boleh jadi pengganti kepada protein. Contoh macam ayam ke, memang akan rasa ayam. Kalau macam berada pernah makan enoki tak? Mushroom enoki. Tak pernah. Dia memang rasa ayam lah kalau dia goreng.
Okay. Okay. Alright. Okay, anything else nak highlight about your project? Or like
I think our project is very sustainable lah to compared to others because all of this product like very useful even after being discarded. Like it can also be used like to to be as a baja, right?
Baja.
And also it contributes to the 3 sustainability keys, which is that I mentioned before, to reduce the carbon emission, reduce the
Plastic.
agriculture waste, and to reduce the waste
plastic pollution.
Oceans and also help the agriculture sectors.
And also for industrial, our product have met the industrial demand where they want to use the eco-friendly product, right? And also it can be scalable, but it need more kita kena buat research lebih sikit lah untuk cepatkan dia. Mungkin boleh buat fungal strain yang baru ke, sebab selalunya orang akan buat E. coli kan, contoh macam benda lain E. coli, dia akan try untuk engineering DNA. Tapi cuba kita boleh buat oyster mushroom juga untuk DNA engineering tu, untuk cepatkan grow dia.
Okay, that's all from me. Okay, so thank you very much.
Okay.
Alright, thank you.
And the group that has won the second place is Group 4.
Apa saya? Saya bukan student. Oh ni.